You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Server Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Troubleshooting in a server environment must begin with accurate problem identification. This means taking deliberate steps to understand exactly what is happening before trying to resolve it. Guessing at the cause too early often leads to time-consuming misdirection. The CompT Server Plus certification includes this step as a critical part of the troubleshooting process. It requires candidates to be proficient at collecting input from both systems and users to form a clear, objective understanding of the issue being reported. Scoping is the process of defining how large, how severe, and how urgent a problem is. Without scoping, teams may either overreact to a small anomaly or underestimate a major outage. Proper scoping helps determine who needs to be involved, which systems might be affected, and what tools are appropriate for analysis. It also sets boundaries that are important when looking for the root cause of an issue. In the context of this certification, understanding scoping lays the groundwork for later troubleshooting steps. The first task when investigating an issue is clarifying exactly what has been reported. This starts with capturing the exact wording and context from the user or from an automated monitoring system. It is important to separate observable facts from interpretations or guesses. For example, if a user says that the server is down, they might simply mean that an application is slow. Always ask what the user is seeing, not what they think the cause might be. This distinction helps reduce confusion later in the process. After clarifying what is happening, the next step is determining who and what is affected by the issue. This includes identifying specific users, departments, or applications that are experiencing the problem. It is also useful to check whether the affected parties are connected through a specific network segment, data center, or geographic location. Understanding the scope of impact allows you to assess whether the problem is isolated or widespread. This is key information when prioritizing your response. Knowing when the problem started can provide essential clues about the root cause. Establish a timeline by asking the user when they first noticed the issue and whether it has been consistent or intermittent. Aligning this input with system logs, alerts, or scheduled activities can help pinpoint an origin. For example, if a patch was applied an hour before the error appeared, that timing should be noted. Maintenance windows, backups, or even scheduled reboots can all influence when problems emerge. When collecting input from users, it is important to avoid introducing bias into the process. Questions should be open-ended and neutral, so that users can describe their experience without being led toward a specific answer. Technical staff should validate these reports with supporting system logs or monitoring data whenever possible. At the same time, all user input must be treated with respect, even if the user lacks technical knowledge. Non-technical observations often provide clues that automated systems may overlook. One way to reduce inconsistency in user input is by using standardized surveys or structured questionnaires. This approach ensures that each incident ticket includes the same core information such as device type, error message, physical location, and time of occurrence. Standardized data makes it easier to detect patterns or repeated failures. When many users report similar issues using the same format, it becomes easier to correlate events and identify underlying causes. It is also essential to gather objective symptoms from the system and network. These may include slow response times, denied access attempts, automatic reboots, or visible error messages. Some symptoms may be limited to the user interface, while others may only show up in the backend or logs. Tools like performance monitors and SNMP dashboards can help correlate these findings with user reports. The more detailed the symptom log, the easier it is to cross-reference and confirm observations. Comparing systems that are affected by the issue with those that are not can be a highly effective method for narrowing down causes. Differences in operating system versions, firmware revisions, Hardware platforms or recent configuration changes can offer immediate clues. For example, if only systems in one time zone are affected, or only those with a particular patch, this might help isolate the root cause. Unaffected systems effectively serve as baselines for contrast. System and event logs are foundational tools in scoping and initial diagnosis. Collect logs from all relevant layers, including the operating system, applications, hardware interfaces, and centralized monitoring systems. Filter these logs by timestamp, service name, or error code to find relevant entries. Matching log data with user-submitted incident times often reveals hidden correlations. Logs may show failed authentication attempts, resource exhaustion, or system crashes that were not visible to the user. Sometimes the issue being reported has already been seen by others, either internally or from an external vendor. That is why checking change management records, help desk tickets, or known issue databases is a necessary part of the scoping process. Many times, vendors publish alerts or bulletins when new software bugs or compatibility problems are discovered. Maintenance events, if not clearly communicated, can also appear as outages or unexpected behavior. Cross-referencing these sources helps eliminate unnecessary investigation. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Once enough data has been collected, it is important to document a clear scope statement that summarizes what is currently known about the problem. This should include which users are affected, which systems are involved, and what symptoms have been confirmed. A well-written scope statement ensures that everyone reviewing the ticket or responding to the issue is working with the same information. It also supports proper escalation by providing a concise and factual overview. In more complex environments, correlating user-reported symptoms with network diagrams can be especially helpful. By mapping affected devices or services against network infrastructure, patterns may emerge. This includes examining routers, switches, access points, or specific virtual LANs. Visualizing these connection points helps identify whether the root cause might be tied to a shared network segment. This process helps eliminate unrelated portions of the infrastructure from further investigation. Help desk personnel or first-line support teams are often the first to hear about emerging issues. They may have already documented similar cases or recorded symptoms that align with current problems. Their notes, triage assessments, and incident logs can contain valuable early signals. Involving them in the scoping process improves accuracy and helps confirm whether the issue has historical context. Collaboration between levels of support strengthens the overall troubleshooting workflow. It is important during early diagnosis to avoid jumping to conclusions based on past experiences. Every issue must be treated as a unique event until evidence suggests otherwise. Assuming that a problem is the same as a previous incident may cause you to miss critical differences. For this reason, diagnostic efforts should remain evidence-based. System logs, user input, and environmental data must guide the investigation rather than assumptions or shortcuts. As the investigation unfolds, all observations, regardless of perceived relevance, should be logged carefully. Even small or unusual user comments can become meaningful when viewed in context with system events. Using a structured ticketing system or troubleshooting template ensures consistency and reduces the chance of details being lost. These records are also critical during post-incident reviews and for building institutional knowledge for future reference. While collecting technical data, it is equally important to manage stakeholder expectations. Users and leadership teams should be kept informed about what is known, what remains uncertain, and what steps are being taken to investigate. Being transparent helps reduce frustration and builds trust. Clear timelines for updates should be provided, even if no resolution has yet been achieved. Ongoing communication is part of the troubleshooting process, not something separate from it. If the issue must be escalated to a more advanced support team, the problem description should be as complete and clear as possible. This includes specifying the symptoms, the systems involved, the start time, the number of users affected, and the impact on operations. Supporting materials such as log snippets, screenshots, or comparative baselines should also be included. The better the documentation, the faster the escalation team can begin productive investigation without duplicating earlier steps. In conclusion, successful troubleshooting begins long before technical analysis. It requires structured scoping, thorough information gathering, and clear communication. By properly identifying what the problem is, who it affects, when it started, and how it behaves, server teams can dramatically reduce time wasted on incorrect fixes or incomplete diagnoses. In the next episode, we will explore how to reproduce and document issues effectively so that troubleshooting teams can move quickly toward resolution. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.